Hello everyone. We are looking at phase 3, chapter complex number, exercise 1, and we are at question number 16. Let's look at the question. Complex number alpha, where alpha is not equal to 1. A little bit of correction is here. Be a root of equation. Okay. All right. So here again, this is z to the power p plus q minus z to the power p minus z to the power q plus 1 is equal to 0. A little correction in the equation given. It's a very standard question. Where alpha is not equal to 1, be root of this equation, where p and q are distinct primes, show that this and this are true, but not both together. Okay, so as in the last few questions, this again is a very classic question where we have to get into depth of the complex number understanding. So first thing first, let us first factorize this. What is it looking like? Z to the power p plus q minus z to the power p. So clubbing these two together, z to the power p, this is z to the power q minus 1, z to the power q minus 1 is equal to 0. So this is nothing but z to the power p minus 1, z to the power q minus 1. Okay. Now if our alpha is a root of this equation, meaning alpha to the power p minus 1 is equal to 0, or and alpha to the power q minus 1 is equal to 0. So if alpha is a root of this, then what is it looking like? Alpha is a pth root of unity. Also, alpha is qth root of unity. If you recall the nth root of unity funda, and also it is given that alpha is not equal to 1. So naturally, alpha is equal to 1 is a trivial solution of these two. And if alpha is a complex root of this, then we already know from there, or we can just use GP and you'll come to the same conclusion. So 1 plus alpha square, alpha to the power q minus 1, first of all, p minus 1, by summation also is nothing but 1 in 1 minus alpha to the power p minus 1 minus alpha. We know that alpha is not equal to 1. So this whole thing is going to be alpha to the power p is equal to 0. So from summation also we come to this, and this is a very known expression. And similarly 1 plus alpha square alpha to the power q minus 1 is equal to 0. Okay, so where I am reaching with all this is, if alpha is not a trivial, or it's a non-trivial root of nth root of unity or pth root of unity, then we already know this is a very standard expression, or x to the power n minus 1 is nothing but x minus 1 into 1 plus x square x to the power n minus 1, again from an algebraic expression. So all of that is fine. All of that is fine. Okay. So if this side is 0, then we know this is also 0. Okay. So my question or our question here is that this part, why we know that these two are true, or if alpha is a root of these two factors, then we know from our expression it is either this is true or both can be true. But what we have to first understand, why either of them is only true and not both. The reason being, when we understood or when we learned about third root, cube root of unity, or fourth root of unity, or for that matter nth root of unity, we knew that a unit circle is divided into, if it is a cube root of unity, it was divided into 3 parts. If a fourth root of unity, it was dividing the entire argand plane into 4-sided polygon. If it is 5 root, then 5-sided regular polygon. If nth root, the n-sided polygon. So this here, this is going to be dividing this argand plane into a p-sided polygon, and this is going to be divided into q-sided polygon. Now, p and q-sided sides are not going to overlap each other. The reason being, p and q are co-prime, or in this case, they are just distinct prime numbers. So they are not going to be like a cube root of unity and a fifth root of unity. They are not going to coincide. So that is what has to be understood here. Okay, yeah. Some of the roots, maybe also you can come to the same conclusion. So what I'm trying to get to is that these two are always equal. That is not a problem. The only thing we have to remember is the roots are going to coincide, or a root is going to be like, if it is a part of fourth root or 1 to the power 4, if alpha is fourth root of unity, then alpha is also second or square root of unity, will also be. If alpha is sixth root of unity, then alpha is also going to be the second root of unity. So there has to be a common factor. If alpha is a cube root of unity, then it is also a sixth root of unity. But if the roots or the powers are prime, then it will not be for both because of the multiplicative nature of the root. So that's what we have to remember here. That here, for both, it is not going to satisfy. Thank you.